going to look at inscribed angles, okay? What we did yesterday was central angle. Remember, a central angle, where's the vertex? The vertex is at the center. So an inscribed angle is when the vertex is on the circle. So here's an angle ABC. So the vertex B has to be on the circle. It can't be inside the circle. It can't be outside the circle. Okay. Now, there could be different cases. One could be where the center happens to be on one of the sides. This would make this side a diameter, right? And then this would be a chord. You could have the center is inside the angle. That's fine, right? Or you could have the center outside of the angle. So it could be any one of those three cases. All right, so got one inscribed angle theorem. Really simple. The inscribed angle is half of the intercepted arc. So that means the measure of angle 1 is half of the measure of AB. So if I told you arc AB was 100 degrees, then angle 1 would be half of 100 is 50. Or if I gave you this was 60 degrees, then we would know the arc would be 120, right? Good. Okay. Of course, we're not going to make it that simple that we just give you one angle inside. We have a whole bunch of angles inside. Now, anytime, right? So A, B, C, and D could potentially be vertices for our inscribed angles. Let's see what we have. We have measure of arc AB is 140. Measure of arc BC is 100. And of course, these are not drawn to scale because clearly that looks bigger than that one, but that's okay. And what else do we know? Measure of angle AD and DC are equal to each other, which again, they don't look like it, but we're just going to go with it. Okay, we're just going to say, all right, those look congruent. Okay. Can we find angle 1 yet? Okay, so here's the key. You
DC is 140, right?
Look at angle 1. It helps to kind of trace over it. Angle 1 has what arc as its intercepted arc? It has arc AD. Now, I don't know what arc AD is, but I know these two arcs and I know these two are equal to each other. Could I figure out that arc length?
Yeah.
Okay, the whole thing has to add up to, okay.
Well, semicircle.
So we have 2x plus 240 equals 360. So 2x equals,
We're getting 240.
adding 140 and 100.
So 60.
So x is 60. So, well, there's two arcs that are both the same. It tells us. It says they're equal. Okay? So if if the arc is 60, then angle 1 has to be 30. Right? Because angle 1 is opposite 60 degrees, so it's always going to be half of it. All right, how about angle 2? So angle 2 is the same as angle DBC.
So it's also 30, right?
Yeah. Here's angle 2.
It's also 30.
It's also 30 because it's half of the arc across from it, which is 60. What's wrong, Ariel?
So that makes,
I don't understand how do you know it's the opposite?
Well, look, it goes ABD is the same thing as angle 1. What is the arc directly opposite angle 1? It's always going to be half.
so does that make measure of angle 350?
Yeah, so let's look at angle 3. Angle 3 is opposite the BC, which is 100, so that makes it 50. How about angle 4? Good, because it's opposite 140. And last, we have angle 5, 50. What do we notice? Here's angle 5.
Oh.
So look across from it, it's 100, so it's going to be half of it, which is 50. What do we notice about angle 3 and angle 5? They're the same because they have the same arc directly opposite. So that's actually the theorem below. If we have two inscribed angles, so angle C and angle B have the same arc that's directly across, so they have to be congruent to each other. This is not alternate interior angles. It almost looks like if these were parallel, but it's not the same. They're on the same side.
So for this one.
So, yeah, if they intercept congruent arcs, then the angles have to be congruent.
Why are we like learning about like lines?
Okay. Okay, so angle S and angle R are both opposite angle or arc TQ. So they have to be equal to each other. Okay, so let's set. Let's give everyone a chance. I know, I didn't give you any kind of crazy equations here. These are pretty straightforward. But as usual, we're not done when we solve for x, because what are we looking for? Measure of angle R.
47.
We got, and does it matter? If you had time on a quiz or a test, wouldn't you want to plug it into both just to make sure that we get the same answer? Yeah. So if I plug 5 in here, 9 times 5 is 45, plus 2 is 47. 12 times 5 is 60 minus 13, 47. Yes, Ariel?
Couldn't you also do 12x minus 13 is equal to 2 times 12x minus 13?
No, you just want to set them equal to each other. 94.
Worse than that? How do we know that they're congruent?
The theorem that is just above there.
If they share the same.
They share the same arc.
Yeah, exactly.
If they share the same arc,
Think about that.
right? This and this are both opposite the same arc, so they have to be equal to each other. I don't need to know anything about the arcs. I don't need to know the measures. Did you have a question, Liam?
Yeah. Can you come to our health class tomorrow?
I don't think you have it tomorrow.
Dude, H period is after bonus.
You too.
I'm sure everyone's talking.
Okay, we're good?
You're right, it has been a minute.
Okay.
She gets mad at Alan for sleep.
It's not just me. She
don't
goes
mind
down the
Okay.
road tapping everyone's head because we're all asleep.
Don't fall asleep.
It's not just me.
Is it that
He's always
hard?
Sleeping, but he's in the
Pretty
back, so
hard.
he gets the privilege.
It's so hard not to. Which one are you guys on?
Max is also sleeping.
Okay, but we're learning here, so.
Yeah, why wouldn't you? You're in the you're in the seat. You're just sleeping.
Okay, well, we can have this conversation. It's okay, Alan. It's okay. It's you're not falling asleep in here.
It's not just me.
Okay.
I fall.
Owen blocks me.
Yeah, that's why you can sleep.
Okay. We have an inscribed angle of a triangle intercepts a semicircle. This is our semicircle here.
Like
So what does it intercept mean?
like it connects.
It connects to it, right? Do you see this triangle?
It's connected to both sides of the circle.
Right. Do you see how this triangle is attached to the semicircle? Okay. What kind of triangle does that have to be then? Acute, obtuse, or right?
Right.
How much is a semicircle? 180. So doesn't this have to be a right? Remember, this is a diameter right here. So if it's cutting it in half, we know that a semicircle is 180, so across from it has to be half of 180. That's how we get our 90.
One of those too bad.
Okay. All right, so we have two triangles are inscribed in this circle F, and AB is congruent to BD. We know measure of angle 1 equals 12x minus 8, and angle 2 are 3x plus 8. We want to find each of the following. Okay, so angle 1 and angle 2, we have... What are we going to do, Justin?
Couldn't you do? It's a whole bunch of numbers. Couldn't you do 90 plus 12x minus 8 plus 3x plus 8 equals 1?
Yes. So here, this...
It's not the whole point of that.
Isn't this a right triangle? So don't we know all the angles have to add up to 180? And not only that, but don't we know angle 1 and angle 2 have to add up to 90? Because if we already know one of the angles. So I'm going to take 12x minus 8 plus 3x plus 8. Let's set that equal to 90. If you want to do plus 90 equals 180, it's all going to work out the same. This is just one less step. Okay. Oh, this is nice because the 8's just cancel. 15 into 90. 6.
Yeah.
Okay. What? So when we want to find angle 1, we're going to plug 6 back in. So 6 times 12, 72. 72 minus 8.
68.
Okay, don't give her a hard time. Okay, plug it back into angle 2. 3 times 6 is
18.
18. 18 plus 8. 26. What do we want to make sure? Angle 1 and angle 2 are complementary, so they have to add up to 90. Do they? Yes. Okay. All right, angle 3 and angle 4. This is also,
To each other, right?
It's a 45, 45, 90.
it's a 45, 45, 90. So looking at this one, if this is this has to be a right angle.
How do you know it's congruent?
It tells us.
Oh.
We can just read it next time.
So if these two are congruent,
Actually, you do. Fine.
okay.
Roast.
You'll get it next time.
You really got me.
Good. So that makes sense why those are both 45, 45.
Yeah.
Okay.
Yeah.
No.
So this is also
Alright.
a right triangle, right?
Also a right triangle.
So the two x equations.
So x plus 4.
It looks like no, it's right.
Oh.
Because if the angle is like it's the diameter, so AB is the diameter.
If this
Then it's
this is a semicircle,
it's weird, but it makes sense.
anytime this is a diameter, it's going to cut the circle in half, right? So we're going to have 180, and then opposite that has to be a 90-degree angle, right? Okay, go ahead and solve for x. What do you get, Max? Come on, it's easy. 9x.
I'm not ready.
Come on.
10.
Why?
I got 10.
Wait, but what about the third angle? Oh, we're finding it. Oh, it's a 90.
Okay, so thank you, Max. And
Can't you just add all of them and equal?
yes, but isn't that an extra step? Because then we have to add 90, and then we just have to subtract 90. So anytime you have a right triangle, I just set the two acute angles equal to 90, but sure, you can add them all three equal to 180. What do we get for,
76.
let's see, 8 times 10 is 80, minus 4,
Oh wait, I wrote 10. Why did I write 14?
and this one's going to be 14.
I literally just wrote 10.
Okay, good questions.
Do you know that Max watched a 3-hour video?
I didn't watch it. I was asleep and it was playing.
All right, last page here. Last page. Turning it over. You're already turned over. He's still stuck on page 12. Okay. Last theorem for today.
Oh.
Okay. If a quadrilateral is inscribed in a circle, Okay. Inscribed means all the vertices have to be on the circle.
I get it.
Okay, right here. The opposite angles are supplementary.
So angle K plus angle M equals 1.
Yes. So measure of angle L and N add up to 180, and K and M. Why do you think that's true? How?
Because that's math.
Something with the
The
sentence.
other two are.
Okay.
complementary.
Well, let's take, here, I'll explain.
Oh yeah, because they intersect at the
Triangle.
they intersect at the diameter.
So if we look at,
Cause
Yeah, their points make it.
they make a line and it turns it into a.
so whatever this is, it has to be half of this arc. And then doesn't M have to be half of this arc? But what are those two arcs have to add up to? 360, right? So what we end up with, if we do that twice, we'll get the two angles have to add up to 180.
Or the easier way to explain this is just 12.
Yes, all you have to do. Their opposite angles are not congruent. These are not parallelograms. They
I
are,
miss like alternate. That sounds fun.
so 8x plus 4 plus 14x equals 180. 8x plus 4 plus 14x. So
I got x equals 8.
so we get 22x equals 176.
Yeah, I got 8.
Okay. Measure of angle S
Oh,
and
that means
measure.
S is 90, right?
90.
S is 90.
Good. So if this is 90, then directly opposite also has to be 90. And angle T,
68.
8 times 8, 64 plus 4,
Now it's
60.
60. Do you want us to write the degree symbol or no?
No, it's, so one of the nice things, it's implied when you put the little M in front that it's degrees. Some teachers are picky about that, but technically you don't need to put the M in front. It's assumed that we're talking degrees. Okay.
Oh, the PS.
Okay, so what do you think? Abby works 5 days a week and works 6.5 hours on each of the days she works. How many hours does Abby work in 4 weeks? So what are we gonna do?
I got it's a C. It's C. It's 130, right?
Yeah.
So how many?
It's 5 times.
It's
if you
5
do
times
5 times
6.5.
4. and
How
then
much
5
does
times
she do in 1 week?
6.5.
5.
One week
times 5.
What did we get? 6.5 times 5. So what's? Yeah, and then
Multiply that times 4.
and what does that give us?
130.
Okay. Oh, this is so easy. Which one is the equivalent to the expression below?
Oh wait. Ooh.
What do we have to do? Combine like terms. So yeah, 3x minus 2x.
Oh, yeah.
It is.
I would ace that question. That's the only question that we did.
What do you do in the PS?